Meeting is
Okay, so I've shared the doc on the screen. Can people see that?
Yes.
Yep.
Yes.
Okay, cool. There's the usual Zoom weirdness about pausing in order to get the microphone to work. So please let me know if the screen sharing has gotten out of date. Okay, so welcome everybody. Thanks for joining. I'm excited to make some progress on QoS, as this has been sort of a long-standing feature that we have needed to have. First, I figured I would make sure we have kind of consensus on what the problem is we were trying to solve. So with that in mind, is there the critical use cases I've written down here? Does this seem to cover what everyone is interested in, or are there other features?
I think there are other features that are arguably not QoS related, like
what?
mutability. Well, like mutability of encryption, or things like multi-attach.
Right. So like
how could we support QoS while preventing abuse of this feature to support those attributes?
Oh, so like basically you're saying that there has to be some way to control that, like some features we would like to be able to mutate, but some we would like to ensure aren't.
Well, I guess there's two ways to look at it. One, we could build something broad enough to support all those features, or if we're going to say, no, we're solving the QoS problem specifically, then I guess if the parameters are not opaque to Kubernetes, then that's one way to do it. But I think that makes the problem much harder to solve, like defining a QoS language that is general enough.
Right.
I guess the question is do we see value in making QoS a first-class resource? Would would users, similarly to how they can directly specify like CPU and memory limits, would they want to do something like that for QoS for storage?
Well, I think the question of whether they want to, but we know that that's where all these requests are coming from. People want to be able to change it. I think the dividing line comes down on whether you want end users to be able to change it through some end user visible API, or whether you want it to be proprietary / something only an admin can do, requires elevated permissions. If it's the former, then you kind of have to make it a first-class feature. I think that's where we came down. If it's something that we just want to have be part of the Kubernetes API so end users can just use it, then we got to find a way to make it a first-class thing and standardize it and get everyone to use that. If it's something that we're okay with it being proprietary or an admin-only function, then you can get away with some of these more squishy, flexible solutions, because admins have to deal with more complicated API objects anyways. Like admins have to deal with the CSI drivers themselves, and they have to understand all the complexities associated with configuring storage, setting up the storage classes, etc.
Just curious, sorry, I was going to add, could resource quotas be used to control that?
Well, you would want to have quotas around the ability to set QoS for your volumes, right? So that you can't basically elevate your own QoS really high and steal all the resources of the cluster. So that's the tool for the admin to prevent individual users from consuming too much. But you still want individual users to be able to say, okay, this volume needs 300 IOPS and this volume needs 3,000 IOPS, so that they can, I guess, tune their volumes.
So you just mentioned one keyword for me. This is Patrick. I've been involved in discussion where someone tried to guarantee a certain IOPS rate, even when other pods misbehave and perhaps try to consume more resources than they should be. And it's entirely unclear to me how this could be enforced on a node, whether it's even possible to implement something like that.
It would require the cooperation of the storage system to do that.
So you...
Yeah, exactly. I think
you plumb QoS enforcement all the way down to the storage system, and the storage system, as part of its feature set, includes guaranteed QoS. You can make that work.
So
but then you
if you have a disk, say just a locally attached disk in the Linux kernel, you probably can't do it well, right?
Well, I mean, you would need some pretty specialized software running on the node where that disk is to make it work.
Just for generic Linux kernel.
Yeah, I mean, you can pretty reliably characterize like how many IOPS you can get out of a disk, but then you have other concerns like what if the CPU gets pegged, and that results that causes a drop in IOPS.
Yeah,
there's always this.
Yeah, my conclusion was that you basically can't guarantee it. There's always going to be some condition that breaks your guarantee, and you lose. So you can do traffic shaping. There is a C group controller that has rate limits that you can apply, but then you need to basically throttle all processes in advance to a certain limit. And even if you have spare IO bandwidth, you can't give it to a process because it might then consume that when it's not supposed to consume it anymore. Okay, but the underlying assumption is that the storage system has a certain number of IOPS, and it can assign that to certain clients, and it will do reinforcement. I guess that's
there do exist. I used to work for a company that had a storage system that had guaranteed IOPS, and if for whatever reason there were extra IOPS available, other processes could take them. But a lot of effort was put into making sure that, at least from the storage system's perspective, everyone was promised a certain amount of resources, and that the pie, and you knew the size of the whole pie. So after you sliced it up, it would tell you, okay, you don't have any more IOPS to give away because we don't have more.
And
we only
the
have
concept,
so many.
yeah, and the concept of IOPS itself, is it who counts them? What counts as one operation? Is it a 5 gigabyte write, or is it 5 megabytes or kilobytes?
It gets very fuzzy. Like it.
Okay.
For the particular system I have in mind, it was defined to be an 8K read or write or smaller.
Yeah. Okay. So you need to define that. Otherwise, you basically can't give any kind of guarantee to the user because they do something else than what you were expecting, or what the system is counting. I guess under all of these assumptions, it kind of makes sense, but it leads us back to the problem. If we put that into the Kubernetes API and we say IOPS, what is IOPS in that context?
Yeah, I mean, I think that's going to be pretty hopeless because so much of this stuff is going to be like implementation. So it's like if we're talking about things that have a local disk, we have a whole set of implementation specific things. If we're thinking about network attached storage, you can do a lot more where you have network throttled on the volume side, but you still have problems like a VM may have a maximum network throughput that's going to kick in no matter how you define things on your volume. And anyway, all of this stuff seems so provider specific that I feel like if we try to come up with something general that fits everyone, we are never going to make progress. And so instead, it seems more useful to define a mechanism for some kind of abstract resources that are going to be specific to, you know, particular volume types, and expose an API that way.
So I think I agree. I think what you can do is you can have like something abstract like a storage class, and you could have multiple of them, and they might not be particularly meaningful, you know, cross clusters or cross implementations, but you could have like broadly like a bronze, silver, gold kind of QoS class, right? That's defined on your cluster. And you could say, okay, these volumes are bronze volumes and these volumes are gold volumes, and have that result in a meaningful difference in their performance level. And the details, again, could be completely opaque, right? Because it's super hard to nail that down, but you could have an API that basically says, you end user can choose and you can change it. That would be doable, right? If you abstract away the details, you could still have a knob that you could turn that makes it better or worse.
Yeah, so I guess that a big question I have is it sufficient to allow users to choose between a bronze, silver, and gold? Or if the provider has like specific features where you can choose like a number of IOPS or a throughput, do we want to have an API that allows users to actually choose those specific parameters? So like to choose, you know, 100K, where 100K is interpreted as something that's specific to the volume type. You know, it's a
what I'm envisioning is
provisioned. Yeah.
What I'm envisioning is an administrator type user would set up the definitions of the QoS classes. So an admin would come in and say, gold means 8,000 IOPS and silver means 800 IOPS, and, you know, or whatever made sense in that particular storage system. So they would have to sort of read the manual and figure out what knobs do I have at the storage system layer, put those into some QoS policy object, and then present those to the end users, and the end users choose from the menu of available options.
Right. So the particular problem that I think I'm interested in solving is a volume that has fine-grained tuning of throughput, and a customer who wants to match the throughput of their volume to their particular workload, you know, in order to optimize cost, you know, in order to get the performance they need, but not overpay for provisioned IO. And in that case, I don't know if a, you know, discrete set of IO classes will be enough there. Like I can see people, you know, always complaining that they need to be able to tune things a bit finer.
Well, so in that world, there's some billing based on your underlying QoS claim.
Yes.
And you want to minimize that billing.
Yeah.
Yeah. I mean,
I was worried about it going the other way. That's precisely what I liked about what Ben was saying, that because there is a cost here, I think the admin does have a role to play in limiting cost and fairness.
Yeah, I mean, I think it's important to realize there's a lot of use cases where the administrator and the end user are different people, but there's also a huge number of use cases where the administrator and the end user is the same person, right? You have your own cluster, you're running stuff on it, and you're trying to optimize your costs. And so in the case where the administrator and the end user is the same person, yeah, you could have a special storage or a special QoS class that just, you know, for this purpose, and you could twiddle it, you know, and try to get it dialed in. And because you're in control, you just make sure that nothing uses that particular QoS class except for the one application where you care about it.
I think another use case that I think might be a little difficult with the class concept is if you want to do something like auto scaling, like say you want to specify a request and a limit, and then you want to be able to burst occasionally. And so I think if it's easier to do that if you actually define things in numbers, and then you can basically, go between a min and max number. But it would be difficult to do that if you had to if you just went between opaque classes.
Well, yeah, and we would need to figure out, do the classes implicitly scale with the volume size? Because a lot of QoS systems are implicitly the bigger the volume is, the more IOPS you get, even at the same service tier. So you make the volume 10 times as large and you sort of get 10 times as much performance at the same tier. Now, not all of them work that way, but a lot of them do, and you have to be able to sort of deal in either language.
So speaking for Microsoft, we would prefer not to use classes and to allow tuning to be set per volume. We'd like to see it done in the same way as capacity. So people can request a certain amount of IOPS, and it's up to the driver whether or not they can satisfy that request.
So I like that idea in terms of it's the best for the end users. It just makes it that much more challenging to find a common language that works for everybody. The big benefit to just turning it into an opaque menu that you choose from with discrete options is that it allows the underlying configuration to be way more diverse than you were ever going to get from a standardized, this is how you ask for story. Because then we'll have to define what is an IOP. Is an IOP 4K or 8K or 16K?
I guess to start, would it be useful to just kind of note down sort of how IOPS and throughput is defined in a variety of storage systems we know, and then we can go down that list and see if we can pull out anything common amongst them all.
From my experience at Red Hat, user wants to actually specify the IOPS. They are not sure what they mean, but because they are used from the public cloud to give IOPS, that's what they want to put. So I think actually classes will confuse them, and they won't know what to do with the gold, silver bonds. So we prefer IOPS as well.
Yeah, I mean, if you go shopping for SSDs, on Amazon, they'll quote you IOPS numbers, and it means something. So people are used to thinking in that way. It's just, I think they're imprecisely defined.
But that's exactly the problem. That you need to map. Then we need to provide some measurement for applications to determine what their IOPS requirements actually are.
Yeah.
Otherwise, it's completely meaningless. That's my problem with this number.
Well, I mean, it's not meaningless. It's, more is still better, right? It's just,
yes, but you can compare, but you can't compare the IOPS provided by your disk against the IOPS requirements of your app, because one is apples, the other is oranges.
Right.
That's true, especially if you have raw block versus file, which are very different. But that's the way a user used to be used. It's not like capacity that we know. It's 1 giga is 1 giga. Yeah.
So are people familiar with the a resource claim cap? It's also known as the dynamic resource element.
Yeah, I kind of know about that. I wrote that. Yes.
Yes, indeed. Great. Okay, cool. So then you can actually maybe answer questions here, because the impression I have of that is that it's kind of it could be used to define a resource that you can have a class which describes some implementation of a resource, and then people can use that as a parameter in their pods. In this case, is that true? Is that the intention, or have I?
No, you're right. The problem is that it kind of has an assumption that all of these resources are going to be managed by the resource driver. So if you end up with a resource that is handed out without this API, and then some pods request it also through the resource allocation API, then who really owns the resource? It basically could be taken from another pod at any time, and then the resource allocation doesn't mean anything anymore. So if you have pods, for example, let's suppose we were to use that API for I/O bandwidth. What happens with a pod that hasn't used that API and it's still trying to use a volume? Does that mean that they have zero I/O bandwidth because they didn't allocate any? It's that kind of problem that you get into when you try to do these more squishy or loosely defined resources through an API that ultimately wants to have fixed guarantees about something is available.
Interesting.
So I think the API works for things like GPUs, where you have this many GPUs, or you can split up a GPU in certain ways, and then the only way to get access to a GPU is through this new API. And then you know that once you have an allocation, this piece of the hardware is set aside for you, and you get your processes, your pod gets access to it.
Right. So then if we had something where a volume declares that it is it needs to be used with as a resource, then if there is a pod that does not declare a resource use, it wouldn't be able to, like, if it has a PBC attached to the volume, it wouldn't necessarily get any IO at all. I mean, I guess it'd be the kind of draconian way to enforce that. Like, would that be useful, or that just cause more problems?
For backwards compatibility, you would need some default, right? The 0 is not a reasonable default. You'd have to set something.
It would only hold for a volume that declares that I'm using this resource API.
Yeah, I think it would still be kind of awkward to have two APIs here. First, the volume provisioning and reference to the volume in the pod spec, and then also the resource claim API to actually be able to use the volume. That might be a confusing API.
Yeah, because I mean, I guess it's a second thing I've thought is that there's actually a couple different ways to go about IOPS as well. Like, that there are some that are going to be per volume. So like, this is like a cloud provider implementation. On the other hand, there's IOPS provision, which is going to be done by pod. Like, for example, if you're going to do a C groups based thing, and probably those two approaches are always going to be somewhat separate, and so, like, how do you have an API that could express both of those is always going to be a bit hard.
Well, you could have two different APIs with overlapping purposes. I mean, there is the storage device is the only thing that knows how big its pie is and how much it can hand out, but it can't enforce anything on the node, right? So even if the storage is promising you 1,000 IOPS, if your network is slow, like, you don't get 1,000 IOPS. That's too bad. Or anything else that can cause problems. But you could still define this, from the storage perspective, this is how many IOPS we're promising you. And then there could be another API that says, okay, on the node, we're going to limit this pod to something, and you have to basically come at the problem from both sides to reliably arrive at the right answer. I don't know. I don't think a unified API could handle all of that, because that would make the problem even harder. But you could have an API that just focused on what the storage system's promise to the rest of the system was.
Yeah, so I guess if we're thinking of like a node-based, a C group-based thing, do we think the resource claim API just works for that?
Well, it's flexible enough that you can have arbitrary parameters. You would still need a resource driver that then knows how to interpret them.
Mm-hmm.
And you would need reasonable defaults for backwards compatibility.
That's the thing, that if someone doesn't use the resource claim API, what kind of access do they get? Is it then a best effort thing where if pods come onto a node or get started that absolutely have requested these resources, what happens with the other processes, and how do you enforce that then? You basically would need dynamic readjustment of IO quotas for processes, so that when something changes on the node, so that you now have pods running that have done the due diligence and reserved a certain quota, that they actually get it. And I'm not sure how to do that.
Maybe just a quick question on the scope. Are we suggesting that we would provide a mechanism within Kubernetes to, with C groups, for example, to actually do the rate limiting or the QoS, or are we just passing the request to the storage drive, the storage system? The storage system would handle that.
Yeah, I think that
both are useful.
We could have both. Yeah, I mean, like I guess that I feel like if there's a C group type approach, there is going to be like node specific stuff. You're going to have to provision a special kind of node that has some kind of resource manager or something that has this like special C group stuff. And so the semantics could be that, like, if you schedule a pod on this node and you haven't made a request for IO, then yeah, like there is some node defined default class or a best effort class. But the point is that we don't necessarily need to define that at the Kubernetes level. Like this could be something that's specific to the particular resource a manager. That's just kind of in the same way. If you don't request a GPU, you don't get one. But in any case, like whether or not you have a GPU is very specific to the node configuration that you have in your cluster. So anyway, like I guess that the thing I'm proposing is, it sounds like if we need to do QoS at a node or pod level, it sounds like the resource claim API might be a good place to start, which means that like the problem now we can just restrict ourselves to the problem of if there are per volume parameters. Does that make sense?
Yeah, I think so. I think if we were trying to do the enforcement at the Kubernetes layer, that would just be quite a big thing to tackle initially. And I think we should just focus on passing the info to the storage system.
Has it been discussed like to do something like out of tree via CRDs to define these properties and apply them via some kind of control plane controller, and we can see how it will work for, like, if you want to move it in tree, or how it will work with PVCs. Like, did we? I joined like 10 minutes late. Sorry. So
no, we haven't. mention that. So, but basically, you're proposing that you could use a CRD to test out, like instead of adding new fields to a PVC.
Yeah.
This would be like a kind of polyfill.
Yeah, like nothing stops the storage vendor from doing that today, right? That you could just have a proprietary way of doing this, and you could just ship it, and nothing stops you.
Yeah, you can define.
I think though the question is do we think there's value to the user to first class a QoS concept rather than having each storage provider implement their own thing?
Yeah, no, I was thinking that we could do something like as a project, like define a QoS resource type, and that can be applied. Like we are assuming here, most of these QoS parameters can be applied via control plane RPC calls. So we could define that CRD, and it will, like, it has the claim ref field, and it will apply it, see how it works out, and then we can take the next step. Like putting it in PVC, it's a very tricky problem to solve, putting it in PVC actually, because like tomorrow somebody will want to come and apply fields that can only be applied on node side, control plane side, like all those complexities. Like, and then we had to, what if a field needs to be applied in both the places? But for example, the same place resources request storage that also has, you modify that, you have to also modify file system. For example, like if there are fields that require both control plane and node side, like RPC calls, is going to be, will be problematic. So we want to, I mean, just my gut feeling is that we should isolate properties into bags of fields where they can be applied, and a separate CRD might be a good place to start rather than modifying for PVC type.
Are you suggesting that there's anything node specific about QoS, or you're suggesting that if we use a more generic type of object that can do more than QoS, then node specific stuff might show up?
Yeah.
Which one is
it? Right now, like IOPS throughput, it sounds to me, okay, this is like, for example, these are like properties of control plane, but it's basically a hash map. So
yeah, I think we want to avoid that, right? We want to avoid this becoming a generic tool just to shove a bunch of mutable parameters through the system.
Yeah, so my point is, like, if you want to keep it separate, then maybe a separate QoS type might be a good idea, and it will allow us to separate those parameters into different fields and how they're applied. Like,
so I agree that QoS should be its own thing, and we shouldn't try to mix it up with other things. I think the main open question is, like, should it be very abstract, just in terms of like a policy with a name that you choose from a menu, and then the details of the policy are basically system specific, or should we aim for some sort of proper definition of like megabytes per second and IOPS and other, specific numbers that are surfaced all the way up to the end user API?
So just a question for Patrick. If we allowed a PVC to have a resource claim attached to it, like, does that seem totally crazy? Or would that be a way to kind of have a general mechanism?
What do you mean with attached?
Well, so just these, like, add a resource claim field to a PVC the same way I think it would have to be
you
PVC.
Can't inline it. You can't put it inside the PVC. It's currently alpha for there's technical reasons and policy reasons. So you could add a field that says you reference a,
yeah.
But then
so that you would have a resource claim ref in a PVC, which points to a resource that would have some I mean, I guess this is sort of going towards the hash map thing, because this is kind of getting us to a provider-specific definition of IOPS.
I think it would get complicated, because when every code that currently looks at a pod and needs to determine whether it uses a certain resource claim would need to check both a direct reference in the spec resource claims array, and it would have to look up the PVC and see whether there's any reference there. I suppose it would be more user friendly this way, but it would also be more complicated for Kubernetes. I think I would prefer to just then tell users that, yeah, this PVC here, if you want to use it in your pod, you have to have a resource claim entry in your pod spec for this. Because then it's the same mechanism. It's a bit more obvious.
Right. Well, I guess if there's the way I'm thinking that the of specific implementations of this, that if a particular volume has provisioned IOPS associated with it, that's actually independent of who is attaching to it. So I don't know if that adds that if this is the particular implementation I have is that when you provision a volume, it has a certain throughput, say, it doesn't care about how many machines this is necessarily attached to, if it even supports multi attach, or if it's just attached to a single machine. It doesn't care about how many processes use that device. All of the throttling's at the volume level, and all that seems perfectly well defined and would not require any decisions to be made like at the time a pod is scheduled or whatever.
I guess Matt, is your use case for using the resource claims so that you can have a pod level QoS?
No, I mean, so the idea here was to attach the resource claim to the volume if there were volume specific parameters that were being set. So parameters that are set at the storage level as contrasted with like a C group based approach.
But
then what does the allocation then mean? What pie are you splitting up when you create the volume? Is it IOPS rate supported by the storage system that provides the volume? Is that the idea?
Okay. Yeah. And that can make sense. I mean, there's always going to be a fuzziness around how many IOPS you really have, but you can round down and then hand out the extras fairly. There's ways to do that.
Does it have any scheduling concerns? Like resource claim seems like embedded within like scheduling, like whether it will be available. This IOPS throughput doesn't seem like it controls at least.
If we attach it to the PVC, it pretty much implies that this IOPS rate is available across the entire cluster, because there's no correlation with IOPS rate for this volume on this particular node. It's really just per volume. That seems to be or per storage system, and it then has to be provided on any node that this volume might end up being used on.
Yeah. That would be consistent with how size is handled.
Yeah, exactly.
My concern is like, is resource claim designed to be used like that? Where it seems to me like reading the proposal. Sorry, Patrick.
No, go ahead.
Yeah, I was saying that like it seems to me it's currently designed to be used at pod level so that the scheduling of the pod can be controlled. If we attach it to PVC, I just don't know.
No, I think it could be done. So current design allows for things to be, or to reserve a resource claim for something that is not a pod. And we haven't really thought about what those other users of a resource claim could be, but making a PVC the user doesn't, or a PV, that's actually one of the questions that I have in that context. Do we attach the resource claim to the PVC or to the PV? And how do we know that the allocation is not needed anymore? So it gets a bit fuzzy when we talk about dynamic provisioning of a volume, because we do have these two objects. But as I guess because it's provided by the user, the user creates the PVC and they create a resource claim for the corresponding custom parameters, attributes like IOPS. It pretty much, I guess it has to be the PVC. So
I mean,
I was
going to say,
yeah.
Go ahead and finish. I don't want to interrupt you.
Yeah, it would be possible to say this resource claim must be allocated, and allocation means that a certain IOPS rate has been set aside for a PVC, and we could record the PVC as the user in the resource claim. That wouldn't be terribly bad. Its question just is who enforces that and who makes this reservation, who undoes it when the PVC gets deleted. So a custom controller would need to take care of that, because right now the core Kubernetes only knows about pods trying to use a resource claim. That's the part that's handled. Everything else would be new.
Yeah, I'm not attached to the idea of resource claims in particular as the mechanism. I mean, what API object we use is a separate concern, but whatever it is, I think it needs to be on the PVC so that the end user can say, this is what I want. The enforcement has to be done by the CSI driver, because it's the thing that knows how to tell the storage, like reserve these IOPS. And then you need to think about for any kind of reconciling when you're changing it, right? If you start off with one and you want to change it to another, you have to think about what that reconcile loop looks like in terms of desired state, current state, changing it, and knowing when you're done changing it. You might end up on both the PVC and the PV, just so that you can write a reconciler that gets to the correct result. And I think that's true whether we're using resource claims and trying to treat them like, use them for volumes instead of pods, or whether you use some other object that's specific to QoS that we invent. I will just say that PVCs are scheduled, just not scheduled by Kubernetes, right? Like the CSI driver internally frequently has a scheduling problem to solve, or where am I going to put this volume? And it frequently uses information about the storage class and any QoS requests in the storage class to make decisions about where to put the volume. So this would just be an extension to that process that's already happening.
There's also wait for first consumer for volumes. So
yeah,
there is some integration with its scheduler, but it's kind of indirect.
Yeah. So just to put out like a concrete scenario, suppose you have a volume which has a provision amount of throughput, and you know your nodes have a maximum network bandwidth. So here you actually know that if you have several volumes with high throughput, you aren't going to be able to fit those on the same node. If we had a resource claim attached to a PVC, like could we even solve that problem, or are the decisions made at the wrong time in scheduling?
Well, I think you have to have both to solve it for both sides, right? Because you need both a node that has enough network throughput to support all the IOPS of all the pods.
Exactly.
And you need the storage controller to promise you that it will have network bandwidth on its side to sync all those requests.
Yeah, and then you have a bin packing thing of, if you have 4 PVCs, any 3 of which could fit on one node, and you have a bunch of pods being scheduled, how do you make sure that you satisfy those constraints? I mean, I don't even know if the scheduler could deal with that now, right? Because it may choose the node. It's like it either assumes the PVC is attached to a certain node, or it's free to wait for the first consumer. Is that true?
Well, I was going to say it's worse than that because all the volume logic in Kubernetes is about attaching to nodes, and then you can have an arbitrary number of pods on the node sharing the volume, unless you have RWOP as the access mode, right? And so it's not about where the pod gets scheduled necessarily, right? Because you could have the volume attached to a node, and then a bunch of pods get scheduled to it, and they're all sharing it.
Yeah, I mean, I think like just in the customer conversations I've had, like that is something that they could understand, that like if you're defining IO for a volume, if they have multiple pods using the same volume, you know, it's well understood that the throughput could be shared among those pods in like a not clearly defined way. I think that's okay.
And you don't have scheduling flexibility for those pods, right? They have to go on the node with the volume.
They have to go on. Yeah, that's true.
So I mean, I think there's two separate problems. There's you know how do you manage the promises that the storage system makes to Kubernetes, and you know that's what I think of as IOPS and QoS. And then there's the separate question of how do you make sure that the rest of the system has enough bandwidth to take advantage of the IOPS storage can provide. You can treat that as a separate problem. We don't have to tackle that, right? We can just say, look, we're gonna make sure that the storage system can make promises and keep them, and that you can change what those promises are dynamically, and everything else is status quo. That would be a step forward, and then later we can come back and say, okay, maybe we need to go a step further and deal with the node side concerns. But I don't want to bite off more than we can chew. And I think starting it from the storage side makes the most sense.
Yeah, and so then if we're going to do it from the storage side, do we really have anything better than an opaque hash map of parameters? Like, it seems like we haven't really decided.
I've heard a few people in this call say that they want actual sliders with numbers.
Yeah, I guess should we, at least start with just, kind of looking at a couple of storage vendors and just trying to like understand how all the various systems currently define QoS parameters. Once we have like, I don't know, like a sample of 10 or 20, then we can kind of see if we can pick out anything from it.
Yeah, sure. I could go ahead and add what we have here at Google that is public to the doc, and I definitely invite everyone else to contribute as well.
If we're going to have... Hey, this may be off tangent, but I'd like to share like what we did in VMware. There was a project which had pretty much similar requirements, but it needed QoS. Basically, storage providers were reporting their own QoS to the vCenter, and people could craft storage policies based on these QoS. Sorry. And this QoS could be anything. Here it's specific to you're calling out IOPS, but it could be anything vendor specific. And people could create a policy and send us to create a disk with this specific policy. And there was an option to look at compliance. The storage providers themselves would report a compliance, saying that if it has satisfied the specific QoS. So that was something which we did in VMware a long time. I just wanted to share it.
Do you have a specific, like, what is that feature specifically called? We can basically look at that as an example.
Oh yeah, so it was the VVOL. So, and based on this. Yeah, but conceptually, it's very, very similar. There are a number of storage providers. Each wanted to report different capabilities. And the capabilities also were reported in terms of range, et cetera, et cetera. There was 10 ways to report the capabilities as such. And as far as the range about, I think the initial idea was to have like set something like IOPS, and everybody had to report these QoS. But I don't remember the reasoning, but I think the vendors did not want to report common QoS. They did want to report something slightly different. They want to their own QoS.
This can be done like in VMware like side, like even today, right? Like you can define storage policies that define those QoS as you want and attach it to a storage class via storage policy parameter, and that controls the QoS of all the volumes created from that storage class.
Yep.
Yeah, so this actually will allow you to modify your storage policy.
Oh, it does. It won't allow you to modify. Yeah, if you want to modify, you have to modify the. Yeah, that's true. It just allows the creation.
Right. So I think that then that will make this more flexible. That's one discussion we were having, whether we should restrict this or should we make this more flexible. Yeah, probably should take a closer look at this.
Do you mean simply by making that field mutable?
You can change from one storage policy to another.
Yeah. So if you change,
can you also change the? You can also change the policy itself, right?
Yes,
well, it's still being right. I guess yeah. So maybe there was a difference there.
It was a bit different. So when you change the policies, you had to apply the policies explicitly. And then the storage provider would get to know that, hey, there's a policy change, and they would figure out if this change in policy, is it able to satisfy it? So that it reported using some compliance statuses.
But if they cannot change, they can keep their original policy.
Yep.
Right?
You can keep the original policies, and even the original policies themselves could be modified.
Right. So it's like, yeah, it's very flexible.
Yeah, that's why I prefer the separate QoS policy type CRD that can be attached to PVCs. Like how Ben proposed, it could be a set of predefined policies, like a drop down. I haven't yet thought through the whole how that will work, but yeah, we can, rather than putting these fields specifically in PVC, we should think on those lines.
And if there were vendor specific parameters defined in the storage class or when the volume was created, the attached policy would take precedence?
Yes, it's more like that, right? It's like you have you can have that defined in your storage class, but then you can actually change your storage class. It's kind of like that.
Well, you can't change the storage class, but
I'm talking about the storage policy that Deepak was
like a QoS class. We want it to be changeable. Yes, we would have to. We'd have to have a story about backwards compatibility.
You can change the QoS class that a PVC is associated with and try to modify the properties. That's
ideally, yes. I think that's sort of that's the easiest thing that we can do, is to have some sort of a generic QoS class object that's opaque and allow you to assign it at creation time and change it later. And that's pretty easy to understand, and you could make it work, and it would be more valuable than what we have today. But some people want more than just that.
Yeah, we probably should look at how this one is done. I mean, the one that Deepak was talking about, just to see if we can, we can do something similar maybe. But that is more than QoS. So.
Cool. So I actually have to run, so I will stop the recording. I feel like we have a couple of AIs to add some specific examples of how people either implement this stuff at a storage level or some like the Kubernetes policy example mentioned. If people could please add that to the doc, and obviously we need to continue discussing this, so I'll set up another session. Does that sound good?
Great, thank you, Matt.
Yeah, thank you.
Cool. Thank you all. This has been super interesting. Take care. Happy Tuesday.